This is a video presentation of a paper which was given at Diagrams 2021 about the number and quality of diagrams in scholarly publications being associated with number of citations. So what we're going to do is to sort of describe some of the motivation and then some of the approach and some of the results that we found in doing that. So the initial motivation was about capturing descriptive statistics about how diagrams are used in conference proceedings. So particularly we were interested in neural network architectures, and this is a subset of AI or machine learning applications. So often in AI, a system is part of the contribution which is being shown, and diagrams are used to articulate that. And that's not uncommon. System diagrams are used in many scholarly domains, and this is just one of particular interest to us. A secondary aim was to identify good diagramming practices. So the idea of using citations as a bit of a proxy for how for the communicative efficacy of the paper, not really how good the paper is, but how good it is at communicating. And so we were hopeful that we'd be able to find something about good practices or good visual encodings that are being used or something like this as part of that. And the approach that we've taken is quite corpus-based, as you'll see. So this is a little bit inspired by Lechner's work, which was presented last year at Diagrams. So at the very high level, we can look at how many diagrams are included in papers. So we looked at ACL 2017, which is the Association of Computational Linguistics. We chose 2017 because that allowed us to do 3-year citation lag, so we can actually see a little bit more about what's going on. The number of papers themselves is going up, so we wanted to just take one particular snapshot so we didn't have to worry about normalizing for years or anything like this. So as you can see from the bar charts on the right here, most papers include a diagram, and most papers include more than one diagram. And it would appear that an optimal number of diagrams is sort of 1 or 2. So, or no, the most common number of diagrams is 1 or 2. So of all the papers, there were 82% contained a diagram. So that's just a basic statistic. So we can see here how prevalent diagrams are in scholarly publications. These papers as well, they have an 8-page limit. So particularly as some of the diagrams are taking up, half a page or so, this is really seen as important by the community. So of those papers that include a system diagram, then papers with a system diagram are more likely to be highly cited. So if you look at on the left, we have these little diagrams which show as towards the right of each half of this is higher cited papers. So you can see a big difference on the right hand ones, which include a system diagram. There's a much longer tail, and that's because they've got many more of these very highly cited papers within that bucket, including a systems diagram. Whereas if they're not including a system diagram, then they're firstly more likely to have a lower number of diagrams, makes sense, but they're much more likely to be very lowly cited. And so I was interested in whether that was about the content of the paper or about something to do with communication through diagrams. And so I was looking at whether we could kind of strip out the effect of whether it was a systems architecture contribution or not. And we found that diagrams were more papers with system diagrams were more likely to be highly cited, even when removing the effect of that. So the way that I tried to do that was to take the word abstract and just do a mapping. So abstract and systems and these kinds of words. It's documented in the paper. So to strip that out, so to sort of add that into the model of number of citations, and it still has a very strong signature coming through about systems diagram inclusions. Another interesting aspect of this, which can also be seen from these charts here, is that papers with a very high number of diagrams had a lower number of citations. So the way that you can see that is for example, so the higher up on this chart it is, the more diagrams it includes. And you can see on the top right, so that's including 6 diagrams, and they're more likely to be low cited. So you can see the shape of the thing is over there, and you can see with all of those ones on the left, they have a much higher peak towards the left as they have more diagrams included. So the sort of interpretation that I have of this is that if people that on an 8-page paper are including 6 diagrams, or sort of certainly more than 4 diagrams, there might be they're losing real estate that can be used for text to articulate their contribution, but also they may not be entirely thoughtful about what it is that they're encoding in those diagrams. So the point here is that diagrams are encoding something which is not commonly looked at, because researchers looking at scholarly publications, they're often looking at the text rather than the diagrams. So the proposal really from this paper is, well, actually there's loads of really important information about scholarly practices which is encoded inside diagrams, and in the behaviors which scholars are portraying through their use of diagrams. And so as we were interested in that, we were interested in whether there would, so not just the very high level of number of diagrams, but whether there was a way of clustering these diagrams. So in these system diagrams, they are very heterogeneous. So we have some other papers at this conference which go into a bit more detail about that. But I was interested in whether whether there was some clustering that would allow us to gain some more insight. So whether we could say diagrams which are very mathematical notation are more effective. Something like that would be fantastic. Unfortunately, that isn't what we managed to achieve. So we tried lots of things. So the visual encoding of tensors. So tensors are basic data encoding which is used in neural network systems. And so because it's so fundamental, I was hoping that we might be able to say something about that very basic building block of styling. But when we went through and classified all of these different types of visual encoding for tensors, we didn't find any pattern that related to the number of citations. So there wasn't a clear cut like this type of thing is somehow more effective for communicating. We also looked at inclusion of specific features, so whether it had arrows, whether it had boxes, whether there were inputs and outputs displayed, these kinds of things. And again, that didn't provide any particular insights. And we looked at visual styling. So we've done some separate exercises to try to cluster together diagrams into visually similar types, and in I think 3 or 4 different ways, which are in various different papers or preprints. And none of those either were clearly correlated with number of citations. So because of that, we were a little bit stumped, to be honest. I'd expected to see that that some particular styling type was better, particularly because some places like Google DeepMind, they produce very influential work, and they have a central diagramming team, it seems, to make their diagrams. So I'd expected to see some of that come out, but we didn't. So what the next angle was in some empirical work, we'd derived a set of guidelines, which are displayed here, which I won't read out. And that set of guidelines was derived from these interviews where I'd spoken to scholars about their use of diagrams and what kind of confusion that they had, and surfaced this up as things that I thought might help. And by converting this into almost a checklist, I was able to say how good the diagrams were in some sense that was derived by these interviews. So I literally just went through and with equal weighting just said, does it use conventional graphical objects where possible? So if it had some obvious violation of that, then I would mark it as 0, otherwise I'd put it as 1. And we checked that that was a reliable way of doing things by having another rater to score it and so on. And it was fine. So there's some additional documentation about how to precisely do that. So plotting this, so the guideline compliance along the bottom is sort of the percentage of guidelines complied with. And so you can see there's 12 columns almost of dots where the instances occur. And then there is the lowest curve. So this is almost like a rolling average of the number of citations, which is on the y-axis. So you can see that guidelines up until about 80% compliance, it's relatively flat. It's kind of noisy. It's just not really anything. And then for 80% or more, we're getting a really, really steep up curve of the more compliant it is, that the higher the citations that we see on the paper itself. So bear in mind, this is some subset of things which occur within a diagram, which here can be correlated with the number of citations. So this is really interesting. We don't even need to know anything about the paper, but we can see that there is something happening there, which I believe is about good scholarly practices. So the part of the reason why my hypothesis for why the 80% is there. So for all of those lower compliance ones, it's a little bit random about whether they're actually complying with them or not. Whereas with the much more compliant, they are, in my view, taking some real care about their diagramming choices and being very thoughtful about it. So I think that's why we're seeing the higher citations there. And if you, just to see this a little bit more simply, we've got a diagram. These are just grouped by amount of compliance. So 70% on the left, 70 to 85% in the middle, and then high citation higher than that on the right. So you can see so these are approximately the same number of papers in each, and you can see how the peak is getting squashed down. So we're getting far, far more highly cited papers in the higher compliance bucket of papers. So hopefully that is a rather compelling case for spending more time looking at diagrams. And so to conclude, we found that usage of system diagrams was correlated with higher numbers of citations, and that higher quantities of diagrams were found to be correlated with a lower number of citations. So again, this is about quality a little bit. And that we found that domain-specific good diagramming practices, which we quantified through this set of guidelines and the compliance with that, were found to be correlated with a higher number of citations. So if this has been of interest to you, then please do feel free to get in touch. I'm always interested to talk to people about diagrams and the neural network system diagrams. So please get in touch or like this video or anything like that. Thank you.